And hello, welcome to this video. In the last video, we actually managed to print every single device and all of the analog inputs, analog inputs and analog outputs on our local system that we saw here. These are virtual DAQ machines. Okay, this is only for the case of devices or DAQs connected in the local neighborhood under my system. If your system happens to be on another system, a remote system perhaps, you might need to use a more advanced technique such as using virtual machines if you want to simulate it on your own computer, or you use an actual DAQ system. Okay, but as of now I don't have access to these just yet, so yeah. And just a note for Python NIDAQ, you cannot it's very difficult to get Python NIDAQ to use these methods here, or these what do you call that, it's very difficult to use Python NIDAQ to use all these methods over here to access remote systems. So you might have to log into the remote system itself, play around with the Linux on that system, and maybe even use Python NIDAQ on that remote system. Okay, so that's NIDAQ for you in Python. Okay, so next step, let's take a look. All right, we want to start reading. Excuse me. I'm still coughing. We want to start in doing some tasks, and we want to read. Okay, as you can see here, let's see. Maybe I'll zoom in a little bit. Why we wanted all these channels in strings is because once we have that, we are able to maybe read a channel. So this channel thing here is a string, okay, and you will be able to read the methods. Okay, so this task thing here is it looks like an object which we need to declare. So we can actually, I guess, import object instance, or use the wrapper to import an object instance of the task and return it to our environment. So that means NIDAQmx.task is well, that's the class declaration, or the object class declaration, and task might be an object. Okay, might be an object for which there are lots of functions here, and then you can just read. Okay, so let's make an object wrapper so that we can put this task thingy into our environment. So let's see, we'll put it over here. All right. Okay, we'll just put it over here. We're gonna do a def. Okay. Def return task object. Then I'll put self, and I think that's it. Okay. The only thing this wrapper does, is to return a task object from NIDAQ. So the overheads are going to be a little bit more problematic, because I'm going to import NIDAQmx every time. So to circumvent that, every time if I call this function, I always do this import NIDAQmx. It's going to be a bit wasteful. So I'd rather import NIDAQ excuse me, import NIDAQ in the class and put it into the self. Okay, so this thing is the constructor I want to put in over here. Okay, def import NIDAQmx self. So import NIDAQmx. So that is what this part is doing. Import NIDAQmx. That's important. Yeah. Okay, self dot NIDAQmx equals NIDAQmx. Maybe I should I should call this build NIDAQmx module. What I'll do here is I will execute it in the constructor self.build NIDAQmx module. Now call this function, and then over here I'll print a space for neatness. Now print NIDAQmx module imported. Use self.NIDAQmx to access it. Alright, so this is going to be a little bit, of course, a little bit lengthy. Every time you call this function. So I'm going to leave it first. Because if we keep printing a lot of lines, it'll be very messy, but I think I'll solve that problem later when it's needed. Okay, so this is the part where I'm going to import the NIDAQmx module, and then of course when I come to the task object excuse me, when I come to the task object, I can just do NIDAQmx equals to self.NIDAQmx. Alright, so that will put NIDAQmx into our return task object, and I will just return the task object into the environment, and that's all I want it to do. Okay, task object equals NIDAQmx dot task. Okay, task. So this is an object declaration. Okay, and then I'll just return it to the environment. That's all it's doing. Return task object. Okay, so of course I want to test it out. I will just call this def task. Okay, and this is where I will run it. So the last ones I will not run. So well, I will need to import the NIDAQmx and the NIDAQmx wrappers all the time. So I think all of these I want to put them under a another function, since I keep using them all the time. I'll just call it def get NIDAQmx object, or NIDAQmx wrapper object. Okay, what's this? What's the objective of this thing here? It's basically to get the NIDAQ object, or maybe I'll just call this the NIDAQ object. NIDAQ object, because that's what I want. I just want to return the NIDAQ object. So the only thing to do is to import Python NIDAQ from Python NIDAQ import. Actually, I just copy and paste this whole thing. Why am I wasting all this time? So I'll just paste it here. Now delete about 3 lines. So I will just return it to the environment. Return NIDAQ object. Alright, and then over at the test task, I can just put NIDAQ object equals to self.get NIDAQ object. Okay, and that will be executed. So once the NIDAQ object is executed, well, I can do a build system. NIDAQ object dot build system. But more importantly, what do I want to do? I want to test this return task object, right? So I'll just put a task object equals NIDAQ object dot return task object. Alright, and that is executing this function over here, which just does the task object, which will return a task object to the environment. And all I need to do is to see whether this task object is valid, I can do a type task object. Okay, and then maybe I'll do a print type task object and print task object. just to see whether this object is valid and does it exist. So all I need to do now is to get my test object again, and this test object, I suppose test object dot test task. Okay, so it will say attribute error. NIDAQmx wrappers has no attribute return task object. Okay, so why do I have that? Probably a syntax error, because I actually spelled out object fully. Maybe I'll just make it consistent here. I'll just use return task object like that. So let me run the test again. Okay, it has no attribute return task object. Isn't it right here? Okay, so probably I'll need to actually do some reloading. So I don't want to reload. Okay, I don't want to reload using that what do you call that? The workspace thing here. I just want to streamline it from import library import reload. So I'm going to import the Python NIDAQ, reload Python NIDAQ, then import the wrappers and return the NIDAQ object. Hopefully, yeah. So I'll need to get this test object again. Then I'll test the task. So that should include the reload now. Alright, so what happens? I actually make sure I have the reload thing when I get the NIDAQ object over here. Once I get the NIDAQ object, which is all my NIDAQmx wrappers over here, I should be able to reload the NIDAQmx object every time I run this function. So when I run this function and I do this test task, so I get the NIDAQmx object or NIDAQ object. I built the system, okay, and of course I imported the module, and this task object is a NIDAQmx task, which is a write object, and if I just print the task, it will just be a task with an unnamed thing. Alright, so that's a success for part 1. Okay, success for part 1. 12:45. Okay, get task object, and the next part will be well, if you look at the code here, we want to add a voltage channel, or in our case maybe we want to add a temperature channel. So usually in the over here under NIMax, what you usually do is to create a new task over here. Alright, oh boy, it's lagging. Alright, so create new NIDAQmx tasks. We can acquire signal, analog input, temperature, thermocouple. So thermocouples, you can do it for module A or module B across any of these channels. So that's just for you to check. You should know, well, I guess you can maybe name this temperature or temp sensor 1, right? Just to make it clear that you know this is a temperature sensor. I can save this, update it, okay, and what I can do is of course test I want to test the printing of name again. So test object dot if I want to check whether it's properly loaded into the system, I want to do a test print device name. Okay, and what's the module? What's the thing? Okay, I have a temp sensor 1 on all of this. So okay, so that's how I find this this thing. Okay, temp sensor 1, and then I'll have all the relevant channels over here. Okay, so So that's how we print all the devices. Okay. Alright, so I think we are going to do the simple one first. Okay, of course ideally I want to have it programmatically grab the names and then, you know, put it into the task object and do a simple reading. But for now we'll just do it the manual way. Excuse me, yeah, we'll do it the manual way. So I know what channel I need, and it's going to be a thermocouple channel. Okay, here it says add voltage channel, but I believe elsewhere, if you take a look, elsewhere we should be able to see some thermocouples. You can see a thermocouple channel. Okay, I can't remember where it is. Okay, let me fast forward and find it for you. Okay, for time's sake, I will just tell you where it is. It's under GitHub, the NIDAQmx Python repository. You have to look into the test directory. It will not be under your examples. So this is the NIDAQmx Python. Go to NIDAQmx, go to tests, and after that you go to something called test channels. Okay, this will tell you how to, or rather, let's see, wrong one. Test channel creation, that's the one. So the channel here we want to look for is, for example, like this thermisistor channel over here. Create AI thermisistor channel. So this is called a thermisistor channel. So I'm going to use this kind of code, and and I'm going to try to put it in. Okay. Okay, so this is under temp sensor 1 or something like that. So let's take the AI thermisistor channel. Alright, AI thermisistor channel. Or rather, I'll just write it manually. Okay. Okay, let's try this. Task object dot add what's the code? AI thermisistor channel vex or something like that. Okay. Alright. Add AI thermisistor channel vex. Okay. We shall see whether this works, right? AI thermisistor thermstr chan vex. Okay. And then what are we supposed to do? We are supposed to name, I think, we are supposed to name one of the channels. They use here this code, AI physical channel equals random choice of X series device X AI physical channels dot name. So I'm not going to use that. This one is something we can use to programmatically grab a name and a channel device. So I'm not going to do that just yet. I'll just type in this thing, temp sensor, temp sensor 1 AI 7, for example. Okay, no need to be precise now. Okay, but we're just going to add this thermisistor channel. Okay, so once we add this thermisistor channel, that's a temperature measurement. Okay, and then according to this documentation, we should be able to start reading a value. Okay, so we're just going to do a task object.read, and let's see whether this works. I have no idea whether this will work, but that seems to be the correct syntax. Okay, task object read. Okay, and let's see. We shall do a task, but I need to get the test object again so as to refresh. Alright, so apparently there is no attribute add AI thermisistor channel vex. So I guess I'll have to look again, maybe in the next video, to see whether it works. But maybe we can add a voltage channel and just see whether that works as well. That's the simplest way. Add AI voltage channel. The AI voltage channel is here, AI voltage Chen. Add AI voltage Chen, and then you're supposed to read it. So you get a test object and then do a test task. Oh, okay. Oh, right. Okay, I'm supposed to put the AI channels over here. Alright, so syntax error again. So let's undo twice. Uh-oh. Okay, let me quit. Yeah, let's quit. I think I messed up. Okay, we're gonna try again. You have a return task object. Good thing I save a pretty, yeah. So what I need to do here is, I need to put a .ai channels in there. Never mind the temperature. So AI channels .ai voltage channel, and then task object later. Okay, we're gonna do that first. Let's refresh the test, and we'll test task, and then all right. So we have something like this, but we have an unnamed task. We added a voltage channel, and then we tried to read it, but apparently there is like no reading just yet, right? Because I think we have not simulated anything there. I don't know how this will work specifically, but yeah, I need to actually run this thing first, I think, so that there's a signal simulation. If not, there's nothing to detect. Let me try that again. Print device name and test task. Okay, so at least we have something. It says DAC error. There's some buffer. This this thing could not be completed as specified. Okay, so at least we have some signal to read, but it's giving us some kind of bug. So I mean, it's a bummer for sure, but at least we have something. And then let's see. So let's check the channel. I don't know what channel this is on. Let me stop. Okay. So normally when you create a task here, you can go and read the temperature. For example, IEX thermisistor, temp module 1, I can put AI6. Now I just call this my temperature task. Okay, and then here I can, I guess, yeah, you can simulate a temperature, and then I can just do a run. Okay, and then it will just like go all over the place. Okay, so let me stop this, and let me look at the chart. Let me run. So it's a sinusoidal wave of some sort that we are going up and down, up and down, up and down. This is looks like some signal generation. Yep. So I'll stop this. Yeah, and this is actually generating signals for us, but yeah, I can't get anything here. It says specified resource is reserved. You'll probably have to do something else, but yeah, at least the syntax kind of shows it's correct. And then the other thing is, yeah, we can finally add AI. Remember what? AI thermisistor. Let's try the thermisistor channel. Thermistor channel vex. I'm gonna copy part of it anyway, and I'm gonna paste it here. Oh, the thing doesn't like work properly. Let me try again. Oh, thermistor. Okay. Add AI thermistor channel vex, and we will put it here. Paste. temp sensor 1 AI0 or AI5. Since we used AI6 just now, we'll try task object.read, and I'm going to comment out the first 2 lines just to see, you know, if it's okay. Okay, I'm going to try running the code and see what happens. Get the test object and test task. Okay, there's nothing running here yet. So I'm going to try running this thing and we'll see what happens. This is a sine wave producing thingy. And let's get test object and test task. Okay, it says this thing is busy. Well, and yeah, it looks like this entire device is busy because I'm running something on it. Okay. So, and I think this thing is actually on channel 6, if I'm not wrong. Okay. So, stop. Yeah, when I stop this thing, it's no longer busy because this thing is actually a task that's running. And once the task is running, I cannot what do you call that? Yeah, I cannot just I cannot start reading it with NIDAQmx for some reason. Okay, so maybe I'll just try it for the last thing, maybe AI6. Yeah, I should get the same error again, but oops. We'll do a test task. Test task. Yeah, we'll still get the same error. Okay, but yeah, the thing is that unless you're using a real DAQ, you'll get this error. The specified resource is reserved. Operation could not be completed as specified, because I think this running this on the NIMax, the virtual channel, right, and generating a signal, and of course here it is also reading that same signal. It makes this resource, you know, not usable by the Python code, okay, the Python implementation of the NIDAQmx. But at least we are onto something. We know we are hitting a spot, and we know what error we are encountering. So thanks for watching. I will see you guys again. Till next time.